we're running a bit off time, so we'll try and keep things on schedule going forward. But I'm going to welcome to the stage today. We've got Saeed, who's here to tell us about how we can do run multiple hosted applications with .NET 8. So I'm going to hand it over to you, Saeed, and let's get going.
Yeah. Hello, Aaron. Thank you. I was enjoying the Conf presentation, but yeah. Okay. Hello, everyone. I'm Saeed. In this presentation, we are going to talk about how to run concurrent hosted services in .NET 8, which is introduced a new feature in our lovely .NET 8. I'm a senior software engineer at 7 Peaks Software. I'm living in Bangkok, Thailand, but I'm originally from Iran. I usually create some posts about the .NET stack on LinkedIn or YouTube. So if you like the .NET tips, you can check my profile as well. Here is the agenda for this presentation. We start with talking about the host. When we are saying hosted service, we need to know what is the host at the first place. And second one, we talk about the hosted service, how they work, and after to know more about what values .NET 8 is trying to add to our projects, we need to do a comparison between what we had before .NET 8 and what we are going to have as new features in .NET 8 for hosted services. And after, we have a quick demo for showing the code in the Visual Studio. What is the host? Host actually is a container that contains some built-in services like dependency injection, configuration, logging, and also contains a set of hosted services implementations. So we have one big object as a host that contains all main objects for our application. Actually, host is responsible for executing all of these hosted services and run one by one and calling those implementations. Here is the IHostedService interface. If we want to go more in the code, there is two methods for the host, start and StopAsync. Start is responsible for starting the application. When we are trying to say always in our .NET application, there is a line at the end of the program CS called app.runAsync, or that app actually is the host. So that run is an extension method for the host, and internally it will call the StartAsync method for running all of this dependency related to our application. So StartAsync will trying to call all of these hosted services, and in any case, if we want to stop our application, this stop method will be called and stop all of these subsequent operation in our application. We have two types of generic hosts. One is the console host and the web host. So usually by design in the console application, we are using the console host. And in case of using web application or web API, the web host will be used. But if we want to know what is the difference between these two types, as I mentioned, host is responsible for running each implementation of hosted services. But in case of using web app or web API, there is one built-in hosted services, which is responsible for running our HTTP server. So there is always one implementation of the hosted service, which is responsible for running our Kestrel as a default and built-in web server. So here is the difference between these two types. And if we want to know what is the point of having one object that contains all of these properties, so it's very easy to control our application, when it start or shut down the application. It's easy to control or disposing all of the resources that is already taken by our .NET application. here is a different part of the host in the high-level image. There is two host service here. Apart from host, when we run the application, we already configured, for example, dependency injection or configuration logging, and then here we are trying to add two host services, A and B, in the order of first A and then B. But what is the hosted services? Everything that we want to run something in background or as a hosted job or as a worker service. Worker service, it means something like Windows services or Linux daemon. We need to implement the hosted service. We have one interface, but different implementation based on the different use cases. By having one interface, we are trying to unify all of these different implementation and different use cases. But there is a set of issues that we can solve them by using hosted services. For example, if we have a periodic background task, maybe we want to do something daily or hourly, we can simply just use the hosted services like the email notification or cache invalidation. Apart from that, okay, there is another tools like the Hangfires or Quartz that we can use already. But here for built-in feature in .NET, we can use the hosted services as well. Another issue that we can use the hosted services, maybe we want to do something only in the application startup, something like data migrations, or we want to hit the cache in the startup and warm it up. So here, by implementing hosted service, we can be sure that that type of operations can be done once, only in the startup of the application. Another one that can be used here for some other process, ongoing process, like calling continuously third-party APIs, or maybe reading messages from a queue. Hosted services is an option to implement those tasks. This is the hosted service interface. It's very simple, very straightforward to use. We have two methods, a start and a stop. We can put our logic in case of we want when application start, we can put our logic in the StartAsync method, and then we can be sure that it will execute by the host. And StartAsync, it's right after we run the application based on the order of the DI, it will be called by the host. And in any case that we want to stop application or restart the application, this stop method, maybe we want to clean up something. Maybe we want to, I don't know, clean up the cache or database. We can put our logic in the StopAsync method, and it will be called in case of the stopping the application. Another one is here again, we have two hosted services, A and B, and each of hosted services contains two methods, a start and stop methods. Moving on, let's try to see what we had before .NET 8 and what is the behavior before .NET 8 and check the issues. Host is responsible for start and stop hosted services, but sequentially. It means the order of registration of our hosted services is important for the host. Is exactly like the ASP.NET middlewares. When we are trying to register our custom middlewares or even using the built-in middlewares, we need to care about the order of the registration for the DI. And hosted service will pick one by one all of these registered hosted services and will call the StartAsync method. But the issue here is it will wait for the StartAsync to be done, and then will go for the next one. Until the current hosted service is trying to do something or takes time, it won't go for the next one. And if we want to see in this picture here, when we are trying to run the host, it will have access to these properties. And then it will take these hosted services from the DI and start calling the start method of the first one. And it will use the FIFO order, first in, first out. So, but here it will wait forever. If our hosted services calling something, imagine that maybe you are doing some calling the third-party API or running some queries on the database. It's okay in a happy day, but at some specific time when you are running the application, maybe that third-party API is down or has some issues that won't respond to you. You maybe again you are trying to you have some retry policy on your calling API. It takes more than usual. So, but host will wait for it until there is some exceptions or you stop the applications. And when it's done, it will go for the next hosted services, which is here the service B, and try to call the start method of it. But in case of the stopping application, it's already run. Our application is run, but we want to stop the application or restart the application. Host will run these and call these stop methods in reverse order. It means in LIFO order. So if we try to stop the host or stop the application, first it will call the stop method of service B, which was the last one that we run the StartAsync method. So it's follow the LIFO order, and then again it waits for the stop method to be done. But here there is a point that we have a host shutdown timeout. We can not wait forever. There is a startup a stop shutdown, that is the shutdown timeout. By default is 30 seconds. So it means if you have multiple hosted services that takes time more than 30 seconds, it will force a stop. Host will be forced to stop all of the subsequent operation. When I say force a stop, it means there is a cancellation token injected to all StopAsync for the hosted services. So that cancellation token will be fired. And all of these subsequent tasks that using those cancellation token will be canceled. But here, if it's done for the service B, it will go for calling the stop method. But what could be an issue here? For sure, first one is maybe we have a slow application warm up. As I mentioned, in case of the web API, always we have one built-in hosted services for starting Kestrel as a web server. But that Kestrel is always the last one of our hosted services. It means if we have some custom hosted services, and those custom hosted services takes time to run, our actual Kestrel won't run. It means our web API cannot serve any request. It will wait for the hosted services to be run and then start listening on a specific port and ready for serving the request. Another one, maybe this is the, we can have some scaling issue. If we want to scale up or scale out our application in some, for example, in the Black Friday, you want to scale up or scale out your application. You want to add some another instances to the API, but for the reason of having multiple hosted services that at that time takes some time to run, your API won't ready to get the new request. So it means maybe in that specific time, you miss some requests. You cannot, you are scaling the application, but those instances are not ready to use. Another one that is more important, it's the possibility of not shutting down gracefully. So it means we have a shutdown timeout. By default is 30 seconds, which is too much, I think. We need to set it less. But in the default timeout, 30 seconds, if you have some hosted services that takes time, but usually in our stop methods for the hosted service, we are trying to disposing something, cleaning some resources, or cleaning the cache. Think about like this, maybe we have query on the database, but the other hosted services take time to run, and then host will be forced to stop the application, and all of those queries will be canceled. Maybe you are trying to set new state or keeping the state updated. In case of cancellation token, maybe you have some data inconsistency, or in any other states that you are trying to clean up, you have inconsistency in them as well. Now let's try to see what features we have in .NET 8. First one is .NET 8 introduced a new interface called Hosted Lifecycle Service, which is very important for having more control over our hosted services. This lifecycle service will add 2 more methods to the hosted service. In the IHostedService, we had the start and stop, but here we have 2 more per methods. For example, in case of the start method, we have one before that, which is a starting method, and one after start method, which is started. This in this order. First one is starting, start, and then started. But what is it for, and what is the use case for this interface? Maybe in some specific scenarios, we want to check some dependencies before actual running in our start method. Maybe we want to check, okay, is it the correct time for running our hosted service, the start method? We can check, okay, that cache service is up, database is up, and then start doing our actual operation. And in the started method, which is running after a start method, we can doing some cleanup or disposing some specific objects based on our logic. And also for the stopping and start, we have it. We can be sure that always this order will be run by the host. Starting, start, and started. Another new feature that we have it in the .NET 8, it will enable us to run hosted services concurrently. This one is actually exactly came for solving some of those issues because of the slowing application warm up. We always need to be careful. Okay, this kind of operation that we are doing in the start async, is it takes time in some specific scenarios or no? It should always be a lightweight task. But here we can use the we can configure the host options. There is new properties in the host options that we can set. Okay, we can run all of these hosted services in parallel, concurrently, and also for the stop async, because in the usual or in the default behavior, the start methods of the hosted services will be run one by one, and also in the FIFO order for the stop, it will call them in LIFO order, but still again sequentially. Here we can run both a start and a stop concurrently, which is really nice for our .NET 8 applications. Again, if we can, we want to check this image here. When we run the host, it will get all of these hosted services from the dependency injection, and it start concurrently calling both start methods for the service A and B. There is it not matter what is the order of the registration, and apart from this service A and service B, if you remember, we says Kesrel is started in one of the hosted service implementation. So Kesrel, service A, and service B will be run concurrently. So in case of, for example, a scaling application, your API immediately will be ready for use. And again, in case of the stop application, both of these stop methods will be called and in concurrent way. But let's check the demo here, just a quick demo for showing the code. Here I have added two hosted service, A and B. In the hosted service A, I just put this await here for 15 seconds to see what happened when we said it will wait for the hosted services. Let's see and how it works. In service B is nothing. Just I put a log here for a stop and a stop. If I run the application here, okay, it wait here is stuck actually, and it's doing nothing. Our API is trying to run the hosted service A. And after hosted service A is done, it starts to run the hosted service B sequentially. We register A and B. And then our actual API or Kestrel start listening on a specific port. It means it's ready to serving requests. But before, no, it was stuck there. And in case of if I want to stop my application, it try to run. This lifetime is for the Kestrel. This one is hosted service B, and the last one A in LIFO order. But what we can do in .NET 8, there is a new option for the hosted service. If I just paste this code here, for the host options, we have two new properties here. Services start concurrently and stop concurrently. By default, still .NET 8 use the default behavior, use the running the hosted services sequentially, which is for sure for keeping the backward compatibility for the old version. But we can set this start and stop concurrently. And if I run now, we expect that all of these hosted services, including Kestrel, will be run immediately. So let's just run it. If it's attached, okay. Yeah, you can see all of these hosted service A run, B run, and then the our Kestrel is run. But hosted service is still running. It's still waiting for that 15 seconds. And we can see after 15 seconds, this hosted service done. But before that, we already have all of these hosted services run in parallel. And also for the stop, they are running in the parallel as well. But here for the host options, there is one more interesting new thing in .NET 8, which we can set the startup timeout. Before .NET 8, when host trying to run all of these hosted services, it will wait forever until there is some exceptions in one of your hosted services. There was no startup timeout. Yes, there was this shutdown timeout, but this startup timeout is good in some specific scenarios that you want to track your applications, in which time some specific hosted services takes time to run. So for example, here you can set 10 seconds. If your application won't run after 10 seconds, you don't need it anymore. Let's stop the application and then check the logs, check the other scenarios, what happened. And the last one that I wanted to check here for checking the lifecycle, let's just remove these things. We don't need it anymore. Here, I just wanted to show the order of the execution. So I implement this interface, hosted life cycle service. And here it's just, again, inherit from the IHostedService services. It's nothing much. But let's run the project and see the what is the order of the calling methods. Yeah. So here, first starting async will be called, and then a start async that is coming from the IHosted service. And then when it's done, it will call the started async. So you can be sure that always this order of the execution of those methods is the same. So you can put your logic, check your dependencies, anything. Okay, let's back to our presentation. Okay, here I wanted to show this code as well. In .NET 8, this is the host code, similar code, but it's the same. When we are trying to run the application, something like this happened behind the scenes. So if we enable the start concurrently for the hosted services, this hosted services enumerable, it's actually host will get them from the dependency injection and do this iteration over all of those hosted services. But we can see that there is a simple, we know all about when we want to run something concurrently in the .NET, we can create a list of the tasks, put this task in that list, and then put this calling the method when all. So this when all, it means all of those list of the tasks will be run concurrently and waiting for all of them to be run. But what we had before .NET 8, it's very simple and straightforward. We have one iteration, one for each, over all of the hosted services, run by one for the start async, and then, yeah, done. So with this reason, .NET 8 improved this operation here for running all of them in the concurrent way. Here is the takeaways for our presentation. Concurrent hosted services is a small but valuable addition to our applications. I think this is this flexibility to decide, okay, in which way we want to run our hosted services is we have the chance to improve our application startup or running our hosted services. But here we need to care about some kind of, if we have some hosted services in our application that has some dependencies to each other, still we need to run those hosted services sequentially, because we need to check what done before this hosted service, what we can do after this hosted service. So it's good, nice, but we need to be careful about this concurrent. Always when we are running something concurrently, maybe there is some chance to have some issues. At the end, I wanted to thank Jose Barbosa for helping me a lot, for help and support for this presentation. You have my appreciation. Thank you, Aaron.
Right. Awesome, Syed. Thanks for your session. So let me check whether there's any question in the chat. There's that number kind of a chat, but there are lots of comments on the awesome sessions. There is before we don't have the knowledge about how the hosted session is working or something like that. So which is really great. Right.
Thank you.
So it's time to say goodbye. Again, thanks, Syed, for joining us, and we will see you next time.
Next year, maybe?
Yeah, next year. Next year at the conference. Bye.
Bye.